everyone, thank you so much for coming to this video. So today we're going to be doing some more on sine, cosine and tangent functions. So make sure you review the other videos we've done when we defined the three functions, and also review the lesson on graph transformations, as that will come really handy for this lesson. So the learning objectives for today is to be able to understand the sine, cosine and tangent functions, their graphs, symmetries and periodicity, and also to know the exact value of sine, cos and tan for specific values. So like always, there's going to be timestamps in the description of the video, so feel free to skip to any parts you want to. So if we move on to the first learning objective about the graphs of the sine, cosine and tangent functions. So I've laid out the three graphs that you need to know here for each of them, and we can go through them individually. So for the first one, we have the sine x graph, and there are some key properties of this graph that you need to understand. So the first one that we have is that if you do sine of 0, that just, if you plug that into calculator, that was just equal to 0. So that means that the sine graph goes through the origin. And the next property you need to know is of symmetry. So here we have it's symmetrical in the vertical axis, and that means that if you did sine of minus x, that would be equal to this minus sine of x. So if we try drawing these graphs, so if we just drew sine x again, like it would go like this. That's like the shape of the graph, with this being 1, and then you have 90, and so you have 180 and 360. So then if we were to draw sine of minus x, if you remember, that's just a reflection of the graph in the vertical axis. So if we were to draw this, then it would just be, this would reflect, so it'd go like, this bit would go like that. And then if we were to reflect this side of the graph, it would just go something like that. And then if we were to do if we were to draw minus sine of x, so let's just draw what sine of x is first. Sine of x goes like this. Then if we were to draw minus sine of x, remember that that's just a reflection on the x-axis. So this bit would reflect here, so we'd go like that, and then this bit would reflect that like that, you go like that. So if you see and if you just label the axis, this will still be 180 in both. So that just means that if you would ever do the sine of minus x, that would always just be equal to the sine of x. So that's the second property you need to know. And the last property you need to know is that the sine of x graph has a period of 360 degrees. So this just means that a period of a graph is just how much when it repeats itself. So a period of 360 degrees just means that the sine graph repeats itself every 360 degrees. So if you were to draw a graph, if you were to do sine of x plus 360, you would just get sine of x. So if you continue this graph, it would just have the same shape, and it would cross a t at 360, so then it would cross again at 360 plus 360. So that means it will just cross again at 720 degrees, and it will continue the same shape as we have here every 360 degrees. So that's just an overview of the sine graph and the key properties you need to know for that. So now let's move on to the cos graph. So moving on to the cos x graph, this is really similar to the sine x graph. The only difference is that the cos graph just shifts 90 degrees to the left then of the sine graph. So that means that if you would do sine of x plus 90. So if you remember, that's just a shift to the left of 90 degrees. You would just get cos of x. So yeah, that's just the relationship between the two graphs. And now if we move on to the properties of the cos x graph. So similarly with the sine x graph, it's symmetrical in the vertical axis. The only difference is if you would do cos of minus x, you would just get that is equal to cos of x. So if we try draw this out just to show you, so we drew cos of x, that would just look like that, and it would go down like that, with this being 90 and this being 270. And then if we were to draw on cos of minus x, so if you remember, that's just a reflection in the y-axis, you would get something. So if you were to reflect this in the x-axis, you would just get something like, I don't know. So if we move on to some properties of the cos x graph, so similarly to the sine x graph, it is also symmetrical in the vertical axis. The only difference is if you do cos of minus x, you just get that as equal to cos of x. So if we draw this out, if we have the graph cos of x, that'll just look something like this, with this being 90 and this being 270. And similarly, this is minus 90 and this is minus 270. And then if we were to do cos of minus x, if you remember, that's just a reflection in the y-axis. So you would just literally get the same graph. So if you reflect this bit, you would get this here. And if you reflect that bit, you would just get like that. If you reflect that bit, you would get like that. And then similarly, if you reflect this bit, you would get this. This bit, you would just get that. And this bit, you would just get that. So basically, yeah, if you do cos of minus x and you reflect it in the horizontal axis, you would just get cos of x. And the last thing you need to know is what the period of the graph is. So like the sine x graph, it has a period of 360 degrees, which means that the graph just repeats itself every 360 degrees. So that means if you were to do cos of x plus 360, you would just get cos of x. So that's just an overview of the cos x graph. So now let's move on to the tan x graph. So if we move on to the tan x graph, this one is a lot different to the other two graphs, as you can see by the shape. So the first main difference is that for the tan x graph, it's undefined with the values of plus minus 90 degrees, plus minus 270 degrees, and plus or minus 450 degrees. So this means that whenever you approach any of these values, and whenever the value gets closer and closer and closer, for the positive values, so for like 90, for example, as you approach it, the values of tan x just gets larger and larger and larger. So they just tend to infinity, but they'll never ever reach 90 degrees, and same for 270 and 450. So that means that these lines here that we have for 90 and 270, these are called your asymptotes. Similarly, so this is similarly like if you approach minus 90 and minus 270 here, and whenever you get closer, you get the same pattern. And similarly, whenever you approach these values, but from the left rather than from the right before, you approach negative infinity, but again, you never touch the value. So whenever you see these horizontal dashed lines at 270, 90, minus 90, minus 270, these are called your asymptotes. So that's the main key property of the tan x graph. And the other property is just that it has like sine and cos, which have a period of 360. This one repeats itself every 180 degrees. So that means it has a period of 180. So if you see here, whenever you have like a period of 180 degrees, like between minus 90 and 90, this whole shape of the graph, that's just repeated again between 90 and 270, and also between minus 90 and minus 270. So for every of these 180 intervals, the graph just looks the same. So that means that this tan x graph has a period of 180 degrees. So this is just an overview of the three graphs and their main properties. So if these just behave like any other normal graph, so if you remember what we were doing about graph transformations, that just applies for these as well. So let's try a few questions that use these graphs just to see if you fully understand everything. So we have an exam question here, so feel free to pause the video and try it out for yourself. I just laid out the three graphs on this slide just if you want to refer to this, but remember that for the real exam you are going to need to memorize the graphs. So we want to sketch the graph y equals cos x plus 60 for values between 0 and 360. So to do that, we just want to have the cos x graph, and we just want to shift it 60 degrees leftwards. So if we draw out the axes here, and we just label some points, let's just label 90 and 270, 180 and 360. So yeah, we can ignore like this bit because we don't need to go in that way. And we just want to shift the graph 60 degrees leftwards. So let's first do it for all the points where it would have crossed the x-axis and shift this leftward 60 degrees. So for 90, it would normally cross at 90, so we want to shift that 60 degrees leftward, so it would now cross at 30 degrees. And then it would also cross at 270, and we just want to shift that 60 degrees, so it would now cross at 210. And then for the points where the other major points is the turning points, so where it was 1 or minus 1. So normally when it was 1, that was at where it was at 0, but now it would be at minus 60, but we don't have to include that, but we can just leave it on for a reference. But because it's only for values between 0 and 360, we don't actually need to include that. And then for the next bit we want to do is for where it was here, minus 1, and that was at 180. So if we subtract 60 from it, that would just be 120. And at that point, it would cross down at minus 1. And at the last one was 360, where it would cross at 1. So if we subtract 60 from that, it will now be at 300. So now we've got our main points here. We can just try and draw the graph. So it would have gone down, so it would cross somewhere here and it would go down, and then it would cross at 30, and the turning point would be at 120, and then it would go up to 210, and then it would go down again. And then if we were to see where it again cross, if it would actually cross at 360 or below, we can work out what the we know that it just goes in 360. We know that whenever we have the 2 points that cross the x-axis, that's always just between 210, and that's between 210 and 30, so they're just a 180 degree gap between the two. And we know that because the graph is periodic, the next time it would cross the x-axis would also be after 180 degrees. So if we were to do 180 plus 210, we would get 390, which means the next time it would cross the x-axis would be at 390. So we could just follow the graph down like this, but then it wouldn't cross until much later. So that's what the graph would look like, cos x plus 60, for between 0 and 360 degrees. So if we now move on to part A, if we move on to part B, we want to write down all the values of x, where cos x plus 60 equals 0. So we just want to write out the points where it crosses the x-axis. So that's when x is equal to 30 and when x is equal to 210. And that's your answer to part B. So this was just a standard graph transformation. You just use the values that you'd have for a normal cos x graph and just do the transformation for each of those main points. So now that we've done this first learning objective, let's move on to the second one. So we want to know the exact values of sine, cos and tan for specific values. So I've laid them all out here in a table. So it may seem a bit daunting at first because you might be like, how am I going to remember all of these for so many values? But don't worry, you really don't have to do that. There's a really simple way that you can actually derive all of these values in an exam if you've forgotten any of them for some reason. So they want you to work in radians. So whenever for the derivation we're going to do, that's all going to be in radians. So the first thing you want to do is you just want to draw an equilateral triangle with each side is going to be equal to 2. And then each angle is just equal to 60 degrees or pi over 3. So all of these would just be pi over 3. And then the next thing, so in order to use, we want to use some sine, cosine and tangent definitions using some right angle triangles to try and derive all of these. So the next thing, you're just going to split this up. And then in order, so now this would turn into 1. And now in order to find out what this side is, we can just use normal Pythagoras theorem. So we would have, if we call this h for height, we would have h is just equal to the square root of 2 squared plus 1 squared, which is just the square root of 3. So now we have that, we can just draw in another triangle like this. So we'd have this is now equal to 1, this is equal to 2, and this is equal to root 3. This angle here is just equal to pi over 3. And this angle, we've just split it into half. So this would just now be equal to pi over 6. And now using this, we can work out, using SOHCAHTOA, we can work out all of the angles, all of the values. So we start with sine of pi over 3. So if you remember, that's just so that's just the opposite over the hypotenuse. So that would, sine pi over 3 would just be root 3 over 2. And we've got that over here. And now if you were to do cos of pi over 3, that's just SOHCAH. So that's the adjacent over the hypotenuse, so that's just a half. Then if we were to do tan of pi over 3, that's just TOA, so the opposite over the adjacent, and that's just root 3. And now we can do the same for pi over 6. So we could have sine pi over 6, that's just equal to opposite over adjacent again, opposite over hypotenuse, so that's just 1 over 2. And then we would have cos of pi over 6, and that would just be equal to SOHCAH, so that's just adjacent over hypotenuse, so that's just root 3 over 2. Then if we do tan of pi over 6, that's just equal to TOA, so opposite over adjacent, so that's just TOA, so opposite would just be, so now you've got to be really careful. Yeah, so you're just going to be really careful because we're doing this angle, so now the right angle is here, so root 3 is now turned into adjacent and opposite, and the side 1 is now turned into the opposite. So now if we were to do tan of pi over 6, TOA, so it would just be 1 over root 3. So that's all the values here that we derived for pi over 6 and pi over 3. So So now let's move on to the ones for the other values. So the last angles that you need to do for the values is just for pi over 4 or 45 degrees. So to do that, you just want to draw a right angle triangle with both sides would be 1 and 1. And then because it's a right angle triangle, then you know that both of these angles would just be equal to 45 degrees or pi over 4. And then we can work out what this side is, again, just using Pythagoras theorem. So this height h, which is like, can label that as hypotenuse, that's so we'll just get h is equal to the square root of 1 squared plus 1 squared, which is just equal to the square root of 2. So this is just the square root of 2. And now if we were to do sine of pi over 4, that's just equal to opposite 1 over the adjacent, over the hypotenuse root 2, so that's just 1 over root 2. Then if we do cos pi over 4, so so that's just adjacent over hypotenuse, so it will just be 1 over root 2. And then if we were to do tan pi over 4, that's just equal to the opposite over the adjacent, so that's just 1. So that's the derivation of the values for pi over 4. So for this one, you just have to draw a right angle triangle with sides both 1. And if you remember for the other one, you drew a triangle with values all 2, and then we split that up into a right angle triangle, and we had this angle was equal to pi over 3, and that angle is equal to pi over 6, and then we could solve everything for these values. So if you did want to work out pi over 2 or 0, you can just do that using the graphs. If you remember that, you just find where at 90 degrees what value it is, and at 0 degrees what value they are. So these are all the exact values of sine, cos, and tan that you need to learn. So remember, if you do forget them in the exam, you can just use the triangle methods to derive all of them. So now let's see if we can apply this to a practice question. So that's everything. Hopefully you found this useful, and you now understand the sine, cosine, and tangent functions and their graphs, and you can also work out the exact value of sine, cos, and tan for some specific values, and you know how to derive this from triangles. So make sure you do some practice questions involving transformation of these graphs, and also make sure you just practice yourself deriving the exact values. But yeah, other than that, thank you.